Hello, dear students. You are welcome to Ark Institute. I am Dr. R. K. Saini. As you know, I keep posting some important question for your NEET examination, JEE, JRF, UGC, NEET, IAS, etc. To continue this program, today I am also going to posting some important question. With help of these questions, I explain or discuss some important fact of chemistry regarding to these problems. So today I discuss some important question, namely question first. This question asked in JEE examination in 2025. This question related to Arrhenius equation of chemical kinetics. First, we read question carefully and then discuss some basic concept and solve the problem. Question first, a graph given between log kf and 1 upon t for a reversible reaction. The pre-exponential factor of forward as well as backward reactions are given. Value of log k. Log k means equilibrium constant is also given at 500 Kelvin, and we find value of log kb at 250 Kelvin. 250 Kelvin. Now we use Arrhenius equation. And this equation related to relation between equilibrium constant, rate constant with temperature. At different temperature range, we find relation for a backward reaction and forward reaction of the rate constant. And hence, according to Arrhenius equation, we know that log equilibrium constant Kb at 500 Kelvin divided by Kb at 250 Kelvin equals to activation energy of backward reaction divided by 2.303 into R into 1 upon temperature T1 minus 1 upon temperature T2. Putting the value now over aim to find Kb at 250 Kelvin. If from the given graph we find activation energy as well as Kf of the reaction. According to the equilibrium constant, we know that equilibrium constant equals to rate of forward constant divided by rate of backward constant. Equilibrium constant given in this reaction log K equilibrium given 6. It means equilibrium constant given 10 to the power 6. And with the help of graph, we find equilibrium constant Kf. Given log Kf given 9. It means Kf equals to 10 to the power 9. The temperature is 1 by 10 in Kelvin inverse is 0.002. It means 1 upon T equals to 0.002. It means T equals to 1 upon 0.002, or we can say 500 Kelvin. It means this equilibrium constant given at 500 Kelvin, and then we find Kb at 500 Kelvin also. With the help of these equations, we find equilibrium constant Kb at 500. 10 K equilibrium constant Kf equilibrium 10 to the power 6, Kf 10 to the power 9 with the help of graph. Therefore, Kb is 10 to the power 3. First, we find Kb at 500 Kelvin, and it is 10 to the power 3. And now we find activation energy for backward reaction and then solve the problem. So we know that activation energy, Arrhenius equation, K equals to A exponent power minus EA upon RT for backward reaction. RT. Therefore, we write K upon A equals to E power minus EA upon RT. Putting the value of this K, backward reaction at 500 Kelvin is 10 to the power 3. Given Arrhenius parameter for backward reaction is 10 to the power 11. And hence, E minus EA upon RT. Solve the problem. Then 10 की power -8 equals to e power minus EA upon RT, or we can say 10 की power 8 equals to e power EA upon RT. Taking ln, therefore ln 10 की power 8 equals to EA upon RT, or we can say 2.303 into 8 into R into temperature 500. It is the value of activation energy, and then putting the value of activation energy as well as Kb in equation number first, and hence our answer is following. Putting the value of log Kb 500 Kelvin minus log Kb at 250 Kelvin equals to, we find EA, then putting this equation, EA 2.303 into 8 into R into 500 divided by 2.303 into R 1 upon 250 minus 1 upon 500. This value is 1 upon 500, then 1 upon 500 cancel, R cancel, 2.303, therefore its value is 8. And the log Kb equals to 10 की power minus 10 की power 3, and hence 3 equals to minus log Kb at 250 Kelvin equals to 8. Therefore Kb log Kb in moderate is answer 5. Okay. Therefore, the question first related to Arrhenius equation, and very important, and this relation is also tell about the activation energy as well as pre-exponential factor for forward as well as backward reaction. Question number second. This question asked in JEE Advanced 2025. Consider the reaction. The rate first we read reaction question carefully and then noted given values and then solve the problem. The rate of this reaction, actual rate of the reaction is K into A into R given in the question. Initial concentration A plus R equals to product. Initial concentration of R is 10 times of the initial concentration of A. Suppose initial concentration of A is A node, then the initial concentration of R is 10 A node. After 40% completion, the concentration of A remains A node minus 0.4 A node and 10 A node minus 0.4 A node, and hence the concentration of A is 0.6 A node after 40% completion, and the concentration of R is 9.6 A node after 40% completion. These concentration putting in equation number 1, and hence the actual rate is K into A means 0.6 A node, R 9.6 A node. This value is K into 5.76 A node square. Equation number 1 on their solving. Now the reaction considered as a pseudo first order, and given K into R equals to K dash, and this concentration remain constant. It means K into R, value K into R is a constant for pseudo order. Therefore, the pseudo order reaction K into R is a constant. This known as K dash and concentration of A. And the initial concentration of R is 10 A node. And this concentration remains constant. And after 40%, the concentration of A is 0.6 A node. And hence pseudo order reaction. And for pseudo order reaction, The rate of pseudo order reaction is K into 6 into A naught square. Equation number second. The percentage error we write rate of pseudo order minus actual rate divided by actual rate into 100. Putting these values, the pseudo order rate is K into 6 into A naught square minus K into 5.76 A naught square divided by K into 5.76 A naught square into 100. K A naught taking common, and these values are cancelled out. Therefore, on solving, the answer is 4.16. The answer is 4.16. J given 1.1 to 1.2. Therefore, your answer is 4.16. Question number third. Question third is related to the electrochemistry as well as thermodynamics. Read careful the question. The electrochemical cell fueled by the combustion of butane at 1 bar and 298 Kelvin. It means given at standard condition, the cell potential is x upon f into 10 to the power 3 volts, where f Faraday constant. Find the value of x. First, we write equation for the combustion of butane at standard condition. C4H10 plus O2, all carbon change into their CO2, and all hydrogens change into water on their combustion. Therefore, we find delta G of this reaction at standard condition. According to thermodynamics, free energy is a state function, and hence it depends upon initial and final state. Therefore, free energy change of the reaction is free energy change of the product minus summation of the free energy change standard condition of the all reactant. Putting the value of product is CO2 and H2O. 4 mole of CO2, the value of 1 mole of CO2 given 394 into 4, and 1 mole of water given 237 into 5, and these are the value of product minus value of reactant. Reactant is N-butane, and their standard enthalpy and free energy given is minus 18 kilojoule. Therefore, our answer, our change, standard free energy change of the reaction is minus 2774, and hence now we find free energy change as well as number of electron take part in this reaction. Number of electron take part in this reaction, and then putting the value minus 2743 kilojoule is the free energy change of this reaction. Right? Equation, and then find n factor of the reaction. The oxidation state of carbon in N-butane. The oxidation state of carbon in N-butane is minus 10 by 4. Oxidation state of carbon is minus 10 by 4. And 1 mole of butane contains 4 mole of hydrogen. Therefore, total charge in left-hand side is minus 10. And on their combustion, it changes into CO2. And the oxidation state of carbon is plus 4. Make balance the atom. Therefore, total positive charge toward the product side is plus 16. And hence we added 26 electron. It means 26 is the n factor. 26 is the n factor of butane on their combustion. And now we know that delta Z equals to minus NFE. NFE standard condition, delta Z is minus 2746 and 43, and n equals to 26. F equals to 96500 coulombs, or potential given X upon F into 10 की power 3. This value given in volt, and we know that coulomb into volt equals to joule. Therefore, this value also multiplied by 10 की power 3, by which kilojoule change into joule. And now find value of X. 10 की power minus 3, cancel out 10 की power minus 3, 96500 coulomb, cancel out by 96500. Therefore, X is 7343 divided by 26, and your answer is nearly 105.5. J given answer 105.5 to 106.5. Okay, this is the question number 3. Question 4. Question 4 and 5 asked in JEE from biomolecules. A decapeptide, molar mass 796, on complete hydrolysis give glycine, alanine, and phenylalanine. The glycine contribute 47% total weight of the hydrolysis product. Find number of glycine unit in decapeptide. First of all, when decapeptide is completely hydrolyzed, then it required 9 molecules of water, because dipeptide made up by 2 amino acids and 1 molecule is lost during their formation. It means when decapeptide is hydrolyzed, then it gives 10 amino acids and required 9 molecules of water. Therefore, the total weight after hydrolysis is 796 plus 9 molecules of water, and the 9 molecules of water is the weight is 126 also, and as the total weight of decapeptide on complete hydrolysis is 796 plus 126, and it is the 958. And now glycine is 47%. It means if weight is 100, then glycine is 47. If weight is 1, then glycine is 47 upon this, and the weight of hydrolysis product is 956, 958, then this is the weight of glycine in decapeptide, in the solution of decapeptide. And the 1 molecular mass of glycine is 75. Therefore, these value divided by 75, and then we find moles of glucose in 1 mole of decapeptide, and your answer is 6. Question number 10. This question is also asked in JEE Advanced in 2025, means current examination. Linear, question first, linear octasaccharide, molar mass given 1025 gram. On complete hydrolysis produce 3 monosaccharide, namely ribose, 2-deoxyribose, and glucose. The amount of 2-deoxyribose is 58.26 weight by weight. Total monosaccharide produced, unit of monosaccharide, particularly ribose, in 1 molecule, 1 molecule of octasaccharide. First of all, octasaccharide means it consists 8 carbohydrates, 8 molecule of carbohydrate, namely ribose, 2-deoxyribose, and glucose. Therefore, suppose ribose, unit of ribose is X mole, deoxyribose is Y, and glucose is Z. Therefore, X plus Y plus Z equals to 8, equation number 1. On the basis of their molar mass, first all of the monosaccharides are linked by a glycosidic linkage and make disaccharides. When disaccharide react with another monosaccharide by a glycosidic linkage, then make trisaccharide, etc. It means octasaccharide also consists 8 molecule of monosaccharides, and after their hydrolysis, we required 7 molecules of water. Therefore, the total weight in the hydrolysis product is 1024 into 1024 plus 7 molecule of water. 1 molecule of water is 18 into 7. And hence total weight in the solution of this hydrolysis become this. And hence it is the, on solving this problem, the total weight is 1150. Now, suppose X mole of ribose ribose is a pentose sugar and their molecular formula is C5H10O5 O5 and their molar mass is 150. Therefore, 150 into X 2-deoxyribose means second position. The second position of carbon lost one oxygen. Therefore, their molecular formula is C5H10O4 and as its molar mass is 134 into Y and the molar mass of glucose is 180. Therefore, 180 into Z and the total weight is 1150. Equation number next. Second. Now we find value of Y. 134 into Y divided by total weight 1150 into 100 and the percentage of ribose or 2-deoxyribose in this solution is given 58.26. On solving this, the value of Y is 5, exact 5. Now the value of Y putting in these equation. First, the value of Y putting in equation first. Therefore, X plus Z equals to 3. Equation number another. And the value of Y also putting in equation second. The value of Y also putting in equation second and on solving the value of X 150 X plus 180 Z equals to 480. The molar mass of 2-deoxyribose is 134 and the value of Y is 5. On their multiply and subtract from 1150. Then we write another relation. Equation number second. Now putting the value of Z in term of X. Therefore, Z equals to 3 minus X. These value putting in this equation, then 150 X plus 180 Z means 3 minus X equals to 480. On solving, we find 30X equals to 60. Therefore, X equals to 2. It is the answer of your answer. And the 2 is we assume X is the moles of ribose and find unit of ribose. And hence our answer is 2. Okay. And these are some important questions from electrochemistry, thermodynamics, biomolecule, as well as chemical kinetics. Okay.